Well, good evening, everyone. Hello, my name is Stephen Hummel, and welcome to our live deep sky tour. As you could probably guess already by the fact that I have the lights on and the dome is closed and the telescope is aimed at this awkward position straight at you, we're not going to be able to do any viewing tonight, sadly, because it's just too cloudy. It's just overcast over the whole sky tonight. It's really a bummer. I'm not too upset, frankly, because, well, we've actually had 11 programs in a row where it's been clear, and we got really lucky with that. So it was bound to happen eventually. We got clouded out. That's kind of just the nature of the program. That doesn't mean we're not going to do anything tonight. I'm going to talk a little bit about this telescope here and talk a little bit about some interesting weather phenomena you can see. But we did check the weather. We have looked at the forecasts. The forecasts tonight called for it to be clear a few days ago, but that's clearly not the case. Um, However, the sunset was gorgeous tonight. I made this time lapse of the sunset. We had some thunderstorms developing in the distance. The outflow from those thunderstorms has caused us to lose our sky for the night, but what a magnificent sunset it was. Just gorgeous, full of colors. Really, kind of almost made up for it. Not totally, but at least we got to see an awesome sunset. Um, but if you have any questions for me, I'm going to try to answer as many questions as I possibly can tonight for you guys. But if you have any questions for me during this program, you're welcome to ask them in our live chat, and I'm going to take as many of them as I can. And our moderators will also try to take some questions for you. But again, I am at McDonald Observatory. If you are not familiar with us, we are located in far west Texas. And in far west Texas, a lot of people think that the summers should be just boiling hot and dry because it's the desert, right? Well, no, actually. The summers here on the top of Mount Luck are relatively mild because the summer is when we get most of the rain for the year. It's monsoon season. We're just now getting into monsoon season here at McDonald Observatory, which means, unfortunately, we're probably going to be clouded out more often. Whereas the past couple of months in the spring, we had almost no clouds at all, just night after night of clear skies. But McDonald Observatory is a research branch of the University of Texas at Austin, and the telescope I'm using is located in this dome by our visitor center. And if you ever come and visit us when we are open, which we're not right now, but when we are eventually open to the public, I encourage you to come to our visitor center, and we usually use the telescopes in these domes down here for you to look at for fun. So I'm going to show you how this telescope here works. And then I'm going to talk about some other interesting weather phenomena, and then I'm going to answer a lot of your questions. So it's maybe a little shorter program, depending on how many questions you ask, I guess, than we typically do. But if you don't own a telescope, if you've never looked through a telescope, a lot of people have a lot of misconceptions about how they work. Because a telescope is basically a big empty bucket. Sticking my hand down the tube, don't usually do that, but just big hollow tube with a big mirror at the back of it. This is the setup most research telescopes use. It's a reflector. So there's a 16-inch diameter mirror at the end of that tube, and that mirror is curved. It's curved. Oh, skipping ahead there. It's curved in such a way so as the light enters through this part, it travels down, strikes that big shiny mirror, and is reflected up to another mirror at the top, which is right here, facing the other way. And if you look carefully at my reflection, you can notice that in the back, the image is slightly magnified a little bit, especially if I put my hand closer, you can see that. So the mirror is curved, it's magnifying because of the curvature, and the curvature is bringing the light towards a focus. But before it reaches a focus, it hits another mirror at the top that reflects the light back down the tube, and then it comes through a hole cut through the first mirror, and then it comes out, in tonight's case, to a camera. As I rotate the telescope around, you will begin to see the camera hanging out the back. And if you're a telescope nerd or into astrophotography, the details for the camera are located in the description. All right, so comes through a hole, and then it comes out to our fancy looking thing that is essentially the camera we use for these programs. Now, the bigger your telescope, the wider that mirror in the back of it, the more light you gather, and the brighter the image, generally speaking, will be. And that's essentially why astronomers continue to build larger and larger telescopes, and why when we talk about a telescope, oftentimes the first thing we say is how big that mirror is. In this case, it's 16 inches, or about 0.4 meters in diameter. But we have much larger telescopes here. For example, we have a 107-inch telescope here at McDonald Observatory, pictured here. And it works the exact same way, just scaled up. A bigger mirror to collect more light. Because the things astronomers generally are trying to study are extremely faint, and we need to gather as much light as we possibly can. So that's really the goal of a telescope. Part of it is to magnify, but that's not the only purpose of a telescope. The real purpose, in terms of why we continue to build larger telescopes, is to gather light. Light, because things we're studying are so faint. If you're curious, a telescope like this, this is a research-grade telescope, so it would not be cheap. When it was new, it would probably cost around $50,000 to $60,000. However, you don't need to spend that much to have a good quality view. If you can get a 16-inch telescope for amateur observing for a lot less than that, maybe $1,000 to $2,000, if you just want to look through it with an eyepiece for fun, which that's all you would really need. Now, this is a little nicer, but it doesn't necessarily mean it's better that you would be able to detect with your eye just looking through it. All right, so again, this section here is the telescope. There are other designs for telescopes, like the thing on top. That is a spotting scope, we would say. It's a smaller telescope that kind of points and gives you a general idea of where the larger one is aimed. So the smaller one has a larger field of view. However, this smaller one is a refractor, which works using lenses, basically the same as a camera lens, just, what we're maybe used to, just slightly bigger and without some of the fancier electronics. And then basically there you go, you have a telescope. A refractor is essentially just a modified version of a camera lens in a certain respect. All right, so if you're trying to buy your own telescope, if you're curious, I would recommend not getting something like this, because this is big and heavy and expensive, and it's permanently mounted to this pier. But the benefit is it's all electronic, and I can control it with this computer, and I can point and track at things very well. If you're buying your own telescope, what I would recommend is a Dobsonian, or Dob, as it's usually called, D-O-B. And so those telescopes are much more portable. They don't have any fancy electronics usually. Sometimes they do, but they're not necessary for it to work. They're basically just a mirror and another mirror to get the light out the side, and then you look through it, and there you go. And you can build a very large Dobsonian telescope without spending a lot of money. And so Dobs usually are the default choice for the amateur astronomer who wants to look through a telescope for fun. Whereas this design is really more optimized for photography and things like science applications like photometry, measuring the brightness of things, or spectroscopy, where we take starlight, break it up, and analyze it. Those sorts of applications. All right, so telescope's cool and all. We got a lot of different telescopes here, and if we do eventually open to the public, you can see and tour some of our larger telescopes. Again, we're not sure when we're going to open up, but you'll see telescopes much larger than this in person, including our Hobby Eberly telescope, which works completely differently with mirrors, but very differently. But I'm going to talk a little bit about what I typically kind of do on nights like this, where the weather isn't so great. We got some thunderstorms off in the distance, and it's too cloudy to do much astronomy. So one of the things I love about living here in West Texas and in their monsoon season are those summer storms where you see the lightning in the distance. And when that happens, oftentimes you can see the lightning, but it's too distant to hear it. And if you're careful, you'll see a very rare phenomenon, which is difficult to see under light-polluted skies. But in rural skies, you can see it, called red sprites. And now I absolutely love these things. I think they are the most awe-inspiring things I have ever seen in person. So when you have a distant thunderstorm, and it's maybe 50 to 300 miles away. So very far. You're not in any danger of getting rained on or having lightning strike you. But when you have a distant thunderstorm with lots of powerful lightning going from the cloud to the ground, sometimes you'll catch these weird jets shooting up above the thunderstorm. Very high above the thunderstorm, those sprites. And there are other related things like elves, tendrils, which some people call trolls, and other weird transient luminous events, as they're called, or TLEs. And what these look like, through a camera at least, are these kind of faint red tendrils shooting up into the sky. And these are some pictures taken recently. And in this example, the storm that produced this red sprite, this emission you're seeing here, was almost 200 miles away, actually a little over 200 miles away. So yeah, there's another example taken recently. That red column coming up, that's over 150 miles away. And even more here from a storm 250 miles, or 260 miles in this case. So they're visible from incredible distances. Here's one taken just a few nights ago, a little more magnified. And so what these are nitrogen atoms, or nitrogen molecules, I should say, that are being excited by electrical discharges from intense lightning strikes. And it is only positive lightning that generates these events. Because a positive strike are far more energetic than negative strikes. You can tell them apart because a positive strike, those are the ones that if you're in the storm, they scare you and they rattle everything around you and they start fires and they come out of nowhere. Whereas negative strikes, those are the ones that flicker. You may see it hit the same spot multiple times. They're not as loud, they're not quite as energetic. They can be scary if you're close, but positive strikes are far more powerful. And it's only when you have those positive strikes, which can be over 1 billion volts, that these sprites are generated. And why exactly do they do that? We don't actually know. We don't really know what's going on exactly, why sprites happen sometimes and not others. They weren't even discovered until 1989. And it wasn't until the last few years that people were ever really able to capture them on camera on a routine basis. But if you have dark skies and you're patient, you can see them for yourself. It's difficult, but you can do it. And they appear as faint gray columns, just like you saw, and they only last a few milliseconds. And they're very common this time of year because we often in West Texas have those big, powerful afternoon thunderstorms, and they tend to linger on as it gets dark. And so they can be unbelievably surreal to see for yourself. If they're very close, you can see the color. But our eyes don't see color very well at night, so usually you don't see that too well. But if you see them for yourself, and if you can catch them on camera, you may even discover something new, because not many people have actually been able to do that on a regular basis. It's still an active area of research. In fact, amateur observers, storm chasers, as recently as a few months ago, discovered a new kind of event associated with sprites that had previously been unknown. But again, they're actually more common than you think. Most powerful thunderstorms do it. You just have to be kind of lucky. And it just so happens that here at McDonald Observatory, we're a little luckier than most, I guess, because I've been able to see them dozens of times in the past month or so. Those afternoon thunderstorms are just fantastic for generating them at night. Okay, so I'm going to take some of your questions now. Try to get through as many questions as I can tonight, because I have got more time than usual to look through them. By the way, if this is your first time joining us for this program, I recommend going to our previous live streams, which have all been recorded and are available on this channel, and watching some of those to kind of see how it typically goes for next time. And the event and the targets for tonight that were listed below, we'll do those probably next time, or at least some of them as possible. So we will try to do one of these later in July. And we'll try to get to those targets. So we're not skipping them. Alrighty, so Ted Betters asks, what kind of telescope is good for an amateur to see galaxies? I have a Celestron 11. Is it good? Yeah, a Celestron 11-inch. That I'm assuming it's SCT, which is a Schmidt-Cassegrain telescope, which is similar to this, just a little modified. Yeah, that'd be great. Most galaxies are relatively small in the sky, so you need a fair amount of magnification to see them well, and they're also very faint, so a large aperture helps as well. Galaxies are some of the more difficult things to see any detail in a telescope, so the bigger, generally speaking, the better. But a Celestron 11-inch, that would certainly be good. The best thing you could do to see more is go to dark skies, away from light pollution, and you'll definitely see more. If you feel like it's underperforming, usually it's because you're trying to observe from light polluted areas. Daniel Roy asks, are you a postdoc? Thanks for all you do. Well, thank you, Roy. I'm not a postdoc. I am just a regular guy. I don't even have a degree in astronomy, technically. I majored in international relations and economics, and I am employed by McDonald Observatory full-time. So most of my work is actually these days is on artificial lights at night and light pollution issues to try to keep the skies dark so we have these marvelous views, which when it's clear we would have, I guess. But yeah, no, I'm not a postdoc. Aaron Davila asks, I remember you saying that this is an RC telescope. What properties make this unique from other reflector telescopes? Yeah, I wasn't going to go into all that detail, but yeah, this is a Ritchie Chrétien, or Ritchie Chrétien, or however you want to pronounce it. I never hear it the same way twice. It's actually almost a running joke among amateur astronomers. How do you pronounce that? So most people abbreviate it RC after the two men who invented it. And what that means is that it's a reflector with two mirrors, and the primary mirror, the big one at the back, has a hyperboloid shape, and the secondary mirror is also a hyperboloid and is convex, so it's bowed outwards. And the benefit of this design is that there's very little distortion. It's as good of an image you can possibly get with two mirrors, essentially. And the downside is that that's expensive to manufacture the curvature of the mirror to the degree necessary. And if the mirrors are even slightly misaligned, the image quality is terrible, and so you have to keep the mirrors perfectly aligned with each other. And this telescope, the tube is made of carbon fiber, so it's very stiff, and there's no flexure between the mirrors, so they try to keep them locked in place relative to each other. Other reflector designs use a different shape of mirror, such as a parabola or a section of a sphere, which are easier to make. They may not have as good image quality, but you can use other techniques to correct for that, such as corrective lenses and other glass elements either at the front of the telescope or at the back to try to undo the aberrations caused by the curvature of that mirror. Whereas in this setup, the two mirrors correct each other's distortions almost totally. It's not perfect, but it's good enough. It's pretty much as good as you can get with two mirrors. Eric Van Gorp asks, what is the best amateur camera for a Celestron 8SC size telescope? And what software do you use to run the telescope and capture the images? For the best amateur camera, I'm going to take that semi-literally, meaning the best you can buy. I guess these days, right now, the ZWO ASI 6200 is very popular. It's a large frame chip, and it's expensive. It's more than a telescope, but that's probably the best right now. Another company called QHY makes an equivalent called the QHY 600. But if you want something that's probably 99% as good but not as expensive, then there are a lot of options especially CMOS sensors these days, which are or what is in most consumer cameras. They're almost as good as the professional level sensors now. They're not quite there yet, but they offer a lot more bang for the buck. And so I recommend a dedicated astro camera that whatever you get, make sure is cooled, meaning it can cool itself down to below the ambient temperature and stay there, because that will greatly reduce the noise you see in the image. That's probably the most important thing, a cooled sensor. All right, I am Rainstorm asks, hi Steven, it's rainy. I finally figured out how to post here. Ha. Do you ever plan on building your own telescope? I have thought about building my own telescope, and I kind of started to once, and I sort of thought it was a little more work than is necessary. I do know some people who have built their own. It is totally possible to grind your own mirror and polish it, and usually have to have someone else coat it, but you can build your own. The mirror is the hardest part, and I just sort of I thought about it, but when I have access to equipment like this, I guess I just never really felt the need to go through with it. I definitely admire people who do build their own telescopes, though. That's a lot of work, and I'm sure the feeling of looking through a telescope that you made and you put the effort into has got to be very satisfying. So maybe one day I will. Julie Valadez asks, how big of a land-based telescope mirror is too big? In other words, at what point does it become more advantageous to shift big money investment into orbiting telescopes similar to Hubble? No telescope is too big. The current trend is bigger and bigger and bigger with no end in sight. Now, Hubble's a great telescope, right? Hubble's very powerful. The mirror on the Hubble Space Telescope is 2.4 meters across. Okay, 2.4 meters. The current largest telescope on Earth, the single aperture, is the Gran Telescopio Canaries, which is 10.4 meters. Way bigger than the Hubble. Our largest telescope here at McDonald Observatory is 10 meters, so just a bit smaller than the largest in the world. And to put something that size into space is just prohibitively expensive. And the benefit of putting things in space is that you don't have to deal with the atmosphere. You don't have to deal with clouds or rain, or you don't have to deal with blurring effects, so you get very good resolution. However, modern ground-based telescopes are accounting for the blurring effects of the atmosphere to match the levels of resolution that can be obtained from a space telescope. So really, there is no limit aside from your budget. And so the next generations of telescopes are just increasingly massive. McDonald Observatory at the University of Texas is partners on a large project called the Giant Magellan Telescope. It's a telescope being constructed in Chile, which will be 24.5 meters across. It's almost 2.5 times the size of the current largest telescope in diameter. There is another telescope in construction in Chile called the European Extremely Large Telescope, which needs a better name. It's not in Europe, and it's not a very creative name. It's in Chile. That's owned by a European group, and that'll be almost 40 meters across. Whereas the next space-based telescope, the James Webb Space Telescope, will only manage 6.5 meters. So the ground-based 40 meters, space-based 6.5. That's the best we can do right now. And the James Webb costs over $11 billion, whereas the current generations of large ground-based telescopes cost maybe 10% of that. So it's better bang for your buck to build it on the ground, but there are certain advantages to being in space that it can't ever come on the Earth, like if you want to observe in the deep infrared or X-rays. That light just doesn't pass through our atmosphere. So that's what you see. All the ground-based telescopes are going to be optical telescopes for the most part. All the space-based telescopes will be in kinds of light we can't see from the ground very well. That's the trend right now. John Priesmeyer asks, are there any recorded accounts of things that could have been sprites by ancient civilizations when the skies were dark, such as the Native Americans or Europeans? It's a great question. I wondered that myself, and I couldn't find. I actually tried to look into this, and I couldn't find any obvious evidence that would, obviously that they saw a sprite. We do know of written accounts going back before the 1980s of people claiming to have seen these things above thunderstorms, but they were always kind of vague, and you know that's understandable considering how brief they are. So we did know about it going back a few hundred years. I don't know of about ancient civilizations. I couldn't find any good evidence that they knew about it. Maybe they did. Maybe it was an oral thing. Maybe they passed the story on to other people, but they didn't write it down, and maybe that knowledge is lost. That's always a possibility. But well, I guess we'll never really know. Or maybe it's out there. Maybe someone else knows, and I don't know it. Krista Rader asks, why were the thunderstorm phenomenons named after mythical creatures like sprites and elves? Because, well, when they first discovered sprites, they didn't really know what it was, and they didn't want to give it like a technical name that implied they knew what it was. And so they came up with sprites because they're very fleeting and kind of hard to catch, and they kind of almost were this like mythical thing for a while in meteorology, or like there was debate at first whether or not sprites were a real thing, and it wasn't really until the 80s and 90s that we realized that they are a real thing. So that's kind of where we got the name. I'm not exactly sure who came up with it. Now they kind of try to make them acronyms. I can't remember exactly what they stand for. They're kind of complicated acronyms. They try to make it more scientific. But yeah, that's just having fun, and I kind of like it because it gives a little flair, which is often needed in science. Trish Rader asks, do you have any photos or pictures of the elves lightning, and what causes that? I do not have a picture of an elf. It's an acronym. However, I know my friend Will Young has one. If you believe him, he might be in the chat right now. The deep sky dude. I know he recently caught on film an elf over West Texas from a storm not that long ago over West Texas. And I don't exactly understand really. I don't know if anyone really quite understands what causes elves. They are much rarer than sprites, but they tend to happen around the same time or immediately preceding red sprites. They're very, very faint. I don't know if anyone's seen one visually. Um, my, my friend Will, he captured it with a night vision device, so they're very tough to see. Um, but yeah, they're enormous. They can be hundreds of miles across. Ramesh Babu Nagarajan asks, what is the best object that can be spotted this month or in July? The best object. I guess it sort of depends. I guess the best one. We have the Milky Way coming up. The Milky Way is low at sunset, right after sunset right now. But if you wait an hour or so, the Milky Way starts to come up. And in the core of the Milky Way, there are a lot of things going on. And in the core of the Milky Way is some really cool nebulae, which we're going to see in later programs, like the Lagoon Nebula or the Trifid Nebula. And if you have good dark conditions, they are magnificent in a telescope. Or the Swan Nebula. They're all kind of clustered in the same area of the sky around Sagittarius. And we definitely are going to see those later on in the year once the Milky Way just gets a little bit higher. I want to let the Milky Way, you know, be pretty high in the sky before we look at some of the stuff there, because the higher it is, the better the view will be. But yeah, the area around Sagittarius, that is a fantastic area of the sky at an amateur telescope. Lindsay Minton asks, what is your favorite dark sky site besides McDonald Observatory? Oh, we took the best one away. Big Bend National Park. I mean, that's not that far away. But it is one of the better places to see the night sky in the United States. I've never been, but I would love to go to Chile. I've heard it's fantastic, and that they have fantastically dark skies and great conditions. And Chile is increasingly well known as being a destination for uh, astrotourists, people who come to see the night sky. And from the southern hemisphere, you see different stars, you see different objects than you see in the northern hemisphere. So yeah, if not here, then probably in Chile, I guess, would be the best. NGA asks, why is Davis Mountain State Park not considered an international dark sky park, even though it's so close to the McDonald Observatory? Well, stay tuned. There's an effort to make it an international dark sky park. It is some. It's a difficult process to become certified as an IDA dark sky park. There are certain uh, requirements. There's a lighting audit where you have to make sure all the lights are compliant, and but there is an effort. We are working with them to help them become a certified dark sky park. They already basically are. It's just a matter, I guess, at this point of almost a formality to get them that last step of the way to get them certified. But yeah, stay tuned on that. A lot of other parks in the area as well are working on that certification. All right, let's see if we have any. I'll take a few more questions and then we'll call it an evening. Uh, Someone asks if we've ever been able to view the northern lights from McDonald Observatory. Ken Hogue asks that. I have not. It has been done. It's very rare to see them this far south. It takes an enormous solar storm or geomagnetic storm to make the aurora visible this far south. It has happened. I believe the last time was 2014. But I have not personally seen them from here. I don't think I've ever personally seen them at all, unfortunately. It's another bucket list thing. Go to Iceland or Alaska or something and see the northern lights. Because up there, of course, they're going to be a lot brighter. But generally, we don't build observatories where the northern lights are common because the northern lights are bright enough to obscure our view of stars and actually interfere with astronomical research. So, generally speaking, that most of the major observatories of the world are in areas where they're far enough towards the equator that they don't really get views of the northern or southern lights. Same thing. Okay, and I'll just take one more question. Um, all right, Charles Phillips asks, do satellites that happen to be in the field of view cause problems? Generally not. There are a lot of satellites up there. There are thousands of satellites in orbit and increasingly more and more. However, there are techniques to kind of remove their effects. If you take a bunch of frames of an image and you combine them together and average them, the frames that have satellite trails will be averaged out, and so that way you can recover some of the data. Now that only works if you have like pictures or frames of data without the satellite. If every single frame has a satellite, then you have a problem, and we have a harder time doing research. And there are concerns that that's the future we're moving towards. However, probably the most famous one right now, Starlink by SpaceX, they are actually working with astronomers to try to come up with solutions to prevent that from happening by keeping their satellites dark. Again, like the International Space Station, for example, it's really bright. You don't need a telescope at all to see it. It's extremely bright when it passes overhead. But we don't really consider it a problem because it's only going to be in a specific spot in the sky for a few seconds. And okay, maybe it photobombs your picture, but you just take another one and you don't really lose that much time. And we can also predict where the brighter ones will be to work around them. But yeah, if there are thousands of them all over the sky and there's nowhere you could look without satellites, then that will be a problem, and that's what we're really trying to avoid. But thankfully, at least in the case of Starlink, the SpaceX is actually they appear to be listening to the concerns of astronomers. All right, that's about all the time we have. If you have any other questions, the moderators may still have some time to answer them, or you can also submit some questions at the forum below in the description. We're going to be back later this week, hopefully, if the weather allows us, with a lunar program later this week, hosted by my colleague Kevin. Now the moon is starting to come into view. It means we're going to shift away from deep sky tours and start looking at the moon again. So we'll probably be back with more deep sky tours later in July, after the moon has gone through its phase and it's not up during the time of our programs. Alrighty, thank you all for joining us and sticking with us, even though it's cloudy. I know it's not the show you came to see, but again, you can always go rewatch a previous one. And thank you all so much for joining me. Clear skies, y'all. And thank you also to my moderators for helping me out.